Alright, so factorising shouldn't be new for most people yet. Yeah? First way, common factors for fairly basic terms. You're looking for something that goes into both terms, in this case the 3. You divide it, you write the leftovers inside brackets. Fairly straightforward. Something you've probably been doing since year 8, I'd imagine. This one, common factors can also have variables in them. If you're really unsure if you've pulled the right common factor out, make sure that you expand it to double check. 5 times x should be this, and 5x times 3 should be this. Yeah?
Yes.
Good. Grouping. Is everyone familiar with grouping?
Yeah.
It's my least favourite method of doing anything.
Not really. We did it a bit last year.
Yeah, we did it a bit last year. It's when 4 terms may have a common binomial factor. And when I say binomial, does everyone know what that means?
No.
No? Bi?
2.
2? So this is a binomial factor.
Oh, I remember this.
2 terms. Right? Nomial is a way of saying number.
I like this. Why don't you like it?
Can I ask you a question?
Sorry.
Yeah. Right. So, when you do grouping, you can only use it when there are 4 terms because you're looking to make 2 groups, hence the name grouping. Alright? The first group, you're looking for a common factor. The binomial factor is irrelevant at this point. But the second group, notice the binomial factor is the same. Therefore, it's a common binomial factor. Once you've done this step here, notice that you can take the factorised portions and put them into their own set of brackets. The common factor is the second set of brackets. It only appears once, even though in the previous line it was written twice. Alright? Do you want me to demonstrate why that happens?
Yes, please.
Okay, so what happens, if I was to ignore this last line and just concentrate on this second last line, if I expand out x squared to x and x squared to 4, and I also expand out minus 3 to x, that's not a good colour, minus 3 into x and minus 3 into 4, notice how this term is multiplied by both of those, and this term is multiplied by both of those.
Yeah.
That is exactly what happens if I expand out this.
Right.
It's just an efficient way of writing it, so I don't have to write it twice, all spread out. Alright? It's only recording it differently because the same effect happens. Remember, everything times everything, which is what we wanted to happen up here. This is a way of spreading it out. Okay? So grouping is not hugely difficult. The only difficulty arises when they try and force you to think what you're doing. They can jumble up the terms. Notice how it's first 2 in a group and last 2 in a group. Sometimes, when you do that, if you take first 2 and last 2, even though they do share a common factor, you might find that these binomial factors are different. In which case, if they are different, you can't take this last step. You have to leave it like that. When that happens, you might have to rearrange the original 4 terms to find a different group. Factorise them and see if they do have a common binomial factor. Alright? Key focus here is not on the rearranging, I don't care about that. What I do care is that you can take this step into here and rewrite them as 2 sets of brackets. Alright? Keep in mind, grouping only works when there are 4 terms. Alright? You can't use it when there's anything else. Okay? Right. Dots or dots. Difference of perfect squares, difference of 2 squares, doesn't matter which. Remember, this is the expanded form and this is the factorised form. The signs are different. So if you see something that looks like this, you know straight away that all you have to do is write it like that. Signs are different, square root of that, square root of that. Job done. Something like this. Notice that first of all I took a common factor out because 3 doesn't have a nice square root and neither does 27. But if I take a common factor out, x squared does have a nice square root and also 9. So it becomes 3 as a common factor and then a difference of perfect squares. Alright? Sometimes they throw variables inside a bracket and then square it. What you're expecting to recognise is that that is a square term and also this is a square term, which is what this says we need to have. Because there is a square there and a square there. Then it just becomes whatever's in here, take away the square root of that, which is this, in one bracket, and then whatever's in the first bracket, add the square root of the second term. Alright, so you can see how there's the 2 parts in here still. So inside the green brackets is what was in the first set of brackets there. This matches with these. And this one has been square rooted from the 16y squared. Alright, often you're able to take that final step and simplify the like terms. So minus y minus 4y is minus 5y, and minus y plus 4y is plus 3y. Notice how now this final step doesn't look anything like that. Nope. Alright?
Hang on, I'm so lost where you got that 5 and 3 from.
So what's 1y take 4?
Oh.
Sorry, minus 1y take 4. And minus 1y plus 4. Does that make more sense? Yeah? So this step here is effectively it, but you can simplify.
But if
Alright.
you put either one, we're correct.
You want to simplify as much as possible. If you can, you should simplify. Alright? So keep in mind, square root of the first, square root of the second, separate them by opposite signs. Right? The only way to do that is to keep practicing. Now, what we'll do is we'll throw in more and more complex examples. You've got to remember, you're still looking at a difference of perfect squares. So long as the first term is squared, the second term is squared, and there is a negative sign between them. Alright? Any questions about those 3 ways of factorising? Those are the 3 ways you probably looked at most commonly in the previous couple of years. No? Good. Right, move on to the fun stuff. Quadratics by sight. Can someone talk me through what they remember about quadratics by sight? How do we factorise them?
The second term is, I don't know how to explain it, but basically that's the addition of the two numbers.
Yep.
The sum of the two numbers.
Sum.
And then the third term is the multiplication.
Product.
Product.
Yep. Great work. So we're looking for two numbers that multiply to make that and add to make that. What are they in this case, Aaron?
Oh, 2.
2 and?
2.
2 and 2.
They're saying cross method.
Yeah, we'll get to that in a second. So, 2 brackets. All you have to do is write down the two numbers that you know to be multiplying to make this and adding to make that. Does everyone know why that works? Because when you expand it out, you're going to have 2 times 2 to make this, and you're going to have x times this 2, which is 2x, and x times that 2, which is also 2x, and you add them together, you have 4x.
So can we just make it x plus 2 squared?
Yes, you can. In this case, you can. Sorry, I had to think there. X plus 2 squared, if they're the same factor. Alright?
Would you get
4.
marks taken off if you didn't do that?
No, not as far as I know. For quadratics by sight, there is literally no working it out that you, like, it's 1 plus 1 kind of thing. Alright? If you really want to go that far, you can put down a list of products that make 4. 4 and 1, 2 and 2. Yeah? It's not hugely involved. 2 numbers that multiply to make 9 and add to make 6, what are they?
3.
3 and 3. Look at that, it's a nice one again. 2 numbers that add to make, multiply to make minus 10 and add to make minus 3. 2 and negative 5. So, just in case you're not thinking as quickly as Shivanti said that, yeah? What you can do is multiply it out. So 5 times minus 2 gets you the minus 10.
Where did you get the minus 2 from? You wrote plus 2.
Sorry, 5 times positive 2. Minus 5 times positive 2 gets you minus 10. And minus 5 plus 2 gets you positive 3. Alright, because when you expand it out, you're going to have 5 times x and 2 times x, and it's going to become minus 5x plus 2x equals minus 3x. Alright? 2 numbers that multiply to make minus 7 and add to make 6.
Negative 1 and 7.
Pardon?
Negative 1 and 7.
Negative 1 and positive 7.
What? Oh, right, yeah. No.
7 times negative 1 is?
Negative 7.
Yep, and then 7 take away 1 is? Positive 6. So I would encourage you to take that last step and just double check them. When you write it down like this, just do it in your head. 7 times minus 1, 7 plus minus 1 is positive 6. Alright? Okay, when you factorise quadratics, you should be looking to make 2 brackets. Alright? 2, 2, 2, and 2. Alright? The power is a good indicator as to how many brackets you're trying to make. So if you have cubics, then go to 3 brackets. Alright? And so on up the chain. Some of them might be repeated. This is what we call a repeated factor. Alright, so lock that away for future reference. Alright, I'm going to erase this side of the board because now we go into factorising things that are non-monic.
What? What's non-modic mean?
Not 1. Alright, so some people already know this one or how to do these ones. I think those signs are the same.
Sorry, I can't do that.
Alright, so difference between these ones and that one. Anyone want to tell me?
There is
Huh?
no common.
There's a number in front of
There's
the
lots
X.
of X. There's nothing
It's the
X.
same amount of x's.
No, lots of X squared.
There are lots of x squared.
X square has a coefficient.
Good use of language. X squared has a coefficient. So if you ever see a coefficient of x squared, like in this case, you can't factorise it by sight unless you take a couple of extra steps. Alright? So our first check. Is there a common factor between 6, 13 and 15?
No.
No, so I have to deal with it as...
I remember this.
So you
Yeah?
multiply with 6 by the 15 and
So-
get the
I
factor.
heard that so many.
I set this up slightly differently to Mr. Cinder, but it's the same process in the end.
What?
It's an X. Why is there an X? Huh?
What are those?
In this box, or this triangle, I want you to write, what is 6 times minus 15?
You're doing what?
6 times minus 15.
90. Negative 90.
Negative 90.
So good at this.
Right? In the bottom triangle, I want you to write down the middle coefficient. Right?
Yeah, no, I didn't do nothing like that.
Now, we are looking for the same as by sight. We are looking for 2 factors of negative 90 that add to make minus 13.
Oh,
So, give me some factors of 90.
10 and 9.
10 and 9. Do they add to make 13?
No,
No,
obviously not.
not going to work. Give me
6
some more.
and 15.
3 and something.
3. Well, what is the something?
Oh,
They have to come in pairs.
18. I don't know.
3 and 30.
30. That's what I said.
Yeah? Do 3 and 30 add to make 13?
No.
No, so give me some more.
10 and
6 and
3.
15.
We've already done 10 and 3 anyway, it's like 30, isn't it?
45 and 2.
45 and 2.
That was Chevy's, by the way.
I think we're getting further away
Yeah,
here.
yeah, that's.
Oh.
You want the close.
Wait.
What's 90 divided by 5 again?
6.5 plus 6.5.
We want products.
3 times 5.
I can't.
Oh,
3 times 5 equals 15.
Okay, what am I doing?
We're looking for
I know.
numbers that multiply
It's
by
18 and
90.
5, but one of them has to be a negative.
18 and 5. 18 and 5 add to make
That
that. Which one
works.
should be negative?
Negative 18.
18 should be negative. Alright, so we've got the one we needed. Notice how we actually had to make a list. There's no shortcut to this. You will have to go through your factors, especially if that number is quite large. Alright, so 18 and 5. Now, they are not the numbers that go into our final bracket. We have to take this back into account. Notice how this number was created by multiplying 6 by 15. So we undo that. We divide by 6.
Shit.
Right? This is now what sits inside our brackets. So our 2 brackets are x take away 18 over 6 and x plus 5 over 6. Can we simplify anything there?
I feel like we can
Yes.
simplify the
Yes.
18.
Into
3.
x minus 3. Now this one, in case you don't know, this is legitimate. It's just not friendly. So what you're allowed to do is write the denominator as a coefficient of x.
What?
Okay.
Yep. You can do that.
I already did that.
So if you look at
Times
this,
both by 6.
6x plus 5, and you wanted to get x by itself, you would have to divide by 6, wouldn't you?
Mm.
And it would become back to the same thing,
Just times
x plus 5/6. But you are allowed to just write it as a denominator, as a coefficient of x. Why might we want to do that? Look at the original equation.
The original equation didn't work.
No, look at the original equation.
Because it has
6x
squared.
It has a coefficient of x squared, doesn't it?
Yes.
This version creates that. The fraction version, you have to manipulate a little bit more to get the 6x squared back.
Yes.
Alright?
I don't really understand the cross.
The cross is just a format of laying it out. Alright? Mr. Sinnott lays it out slightly differently.
Yeah,
Let me guess, he does a
way.
table.
Isn't it like the trick method or something?
He calls it the trick method, yeah.
Oh, I know the trick.
I love
Yeah.
trick
I feel like the method you just did was so much easier.
It's
No,
the same
I don't-
method. The only difference is I wrote it with a cross so I can actually see the product and the two
Can
sets.
you write trick method and show it?
That's just messy.
I'm not confident to go through the way Mr. Sinnott explains it because I do it differently. But I'll give it a go. So Mr. Sinnott multiplies those and then he rewrites it as this.
This way.
And then he just puts his two brackets in, works out what the factors would be, 18 and 5, negative there, x, plus,
Where's the 6?
then
You divide.
he divides them inside the brackets by 6,
Yeah.
Yes,
Yeah.
then he simplifies, and then he will move the denominator.
See, that I get.
Thanks, Hayley. Alright, they're the same method. I like to set it out like this so I can see the actual list here. Right? It might be a way you want to do it, I don't care. Good work. Right.
Then you good.
Would you like another one?
Yep.
You don't really care.
I forgot.
8x squared plus 2x minus 15. Right, you guys do it using whichever method you like. I'll give you a couple of minutes and then I'll do it on the board using my method, not Mr. Sinnott's method. And if you're curious, the book method is different again, which I think is the way you do it. Because you look for splitting 13 up into and then you group them. Yeah. But I said the grouping is my least favourite. That's why I don't like that one. 80 and 40 is 120.
Okay.
Big ass number to get.
Factors 120 that add to make 2. What does that tell you? The addition. Have to be roughly the same number. So you're not going to halve it and multiply by 2 because they're very far apart. You've got to look for two numbers. Maybe you look at multiplying.
Oh, what is this one? 10 and 12. I have
Oh my god, that's so difficult.
Wait, no, don't work it out. I want to work it
I'm not going to work it out. I encourage you to do it.
That's great.
I don't even know why it would be called the trick method. There's not a trick involved.
Well, I don't
He calls it a
care,
trick
works.
method because it's not actual factorising the first bit.
Do you want to know how the book says to do it?
Yeah.
No,
I'm curious.
Book says to go, how can I make 2x? Let's do 15 and 13. Wait, they don't multiply to make what I need them to make. Let's do another 2 that are 2 apart. Yeah. And then group them.
That's not okay.
What is 8 times 15?
120.
Thanks.
Can you factorise this one?
What?
Just give it a go. Any way you do it, when I does it, I don't care, just give it a go. Because you do it, Mr. Sinnott taught you and you and I didn't. Yeah. So you know the trick method. It's just the same.
Wait, did we just last this name?
No.
Really easily.
No. That you, I showed you the other day.
Yeah.
I think I did this right.
You know,
I
I just find these two different.
Shivanti is mine the same.
Yeah, well, you can use a difference. All you know, like the difference here is actually quite helpful because it tells you the two numbers have to be quite close together.
I'm really bad.
Yes.
Did I get this right?
What'd you get?
I don't think I did.
Oh, yeah.
Everybody divide by 8.
But like, that's right.
Where?
Yeah, I got 40 times 5 and 4 plus 6.
Well, I can simplify. Oh,
It's not difficult, it just looks.
It won't go into A. Oh, exactly.
Hey, you do it.
It's easier than
Can I
just,
can I go to the toilet?
Are we trying to locate that one?
Yeah.
2x plus 3, 4x
no,
However you like, you can do it. Cross or length cylinders.
that's not, well, I don't know if I'm right yet. So.
You are.
Oh, I am right? I am right.
Can I start doing it on the board now?
Yeah.
Yay.
How did you get 12 times 2 equals 24?
Together? No. Okay. 12 and 10.
What did you get? I got 4x minus 5 and then 4x minus 2.
Yes.
Remember this?
Minus 5 over 4.
It does, you probably will have different numbers.
I didn't do the first thing, I just went straight.
I know, I got it right. What? Oh. I just didn't simplify first. But would I be marked down for that? Because I mean, I didn't know if you could simplify that or not.
I don't want to hurt your hand. I was like, how did it
Yeah, I know that. But like, I wasn't sure if I can, like, if you simplify one bracket, do you have to simplify one bracket?
Simplification
Sorry.
is a student management process. You're actually renaming. So 6 over 4 is the same as 3 over 2. So why would you have to rename the other ones?
Pretty close.
No, that's very logical. If you operate on one side, so if you change one side, then you change the other side the same. But if you rename, you're not changing.
I would do it.
No, you may.
Thank you.
All right.
Why?
Did everyone get the same answer?
Yes.
2x plus 3, 4x minus 5? Yeah, good.
Does it matter if it's around the other way?
Yes.
Does it? No, it doesn't.
Multiplication, you can switch back and forward. Right, and Kayla had a good question. Kayla got to this point here.
I did not get that.
Right? What mistake did she make? Hasn't simplified far enough. But she was concerned because at this point she'd done this side and she wasn't 100% sure if she could simplify this side without simplifying that side. So she was going to do something to this side, but not to that side. And so she was a bit unsure if that was a rule or not. Does that make sense? Okay? You are allowed to simplify anything without touching everything else, so long as it's simplification and not change. Alright? So this one should have been 3 over 2, shouldn't it? Alright. Does anyone have any burning questions about this? It's fairly straightforward. All you have to remember is multiply the coefficient by the constant. Sorry.
Wait.
Yeah, I did write it the wrong way around. Thank you, Will.
I wrote it down, I'll wait.
Yep. Alright. You must remember coefficient times constant, and then you just go through the same steps as doing by sight. You're just having a bigger number to deal with. Alright? Good thing to remember, the addition in the middle tells you how close the two factors need to be. So 2, the two numbers are pretty close. If you had 13, you're looking for two numbers that are further apart. Alright? No burning questions about this? No? Alright, I'm going to turn it over to you guys then. You can go through set 3B.
And